Data structure in Java continued. This time forming linked list. But the code comes. Now the ones who love writing program, here comes the color of the program, not those visible colors. Yes, this is that wherein one program is now creating the list based on current available memory. So the program is on the action execution, and there during the runtime new memory allocations are getting done, and this process can create a huge list till the memory is available, be it not available even in continuous blocks. Then also if scattered memory is available, this linked list can go on creating new additional elements, can go on adding elements or go on attaching elements to its. Okay, so to bring in that introductory introduction, what to say, introductory whatever. Now A2 is a hexadecimal internal value. Null is obviously a null, means memory address is cleared, no garbage value is allowed to stay. 10 is my data and start is the name of my first node. Okay, we are going to create a stack here. Stack is wherein the new element or the last element gets access first. Now you look at this. The first element is created, its address part is allocated to null. Then the second, or I'll call it the next node gets created. That one's memory allocation is done. Then that one's data part is assigned to some value or is input, and the address part is taken from wherever start was. So start was at A2, starts value was A2, starts data part had 10 and address part had null, but start itself was A2. A2 is a representation of some internal hexadecimal value memory address. Now I have named the new node as move, just a name of a node, and once move is created, then the memory allocation of it is done, then its data part is input, and then its address part is given the value of start. The start's value A2 comes to B4. B4 is the place where the new memory allocation is done. And once the node is ready, start is brought over to wherever move is. And now I can say from start I can access the data part as 20, and from there I can go and access the data part as 10. So this is the connection. Now you can see one more node is to be added to the current list. So in the same way, the new node is created. So when the new node is created, C6 is allotted. Suppose the memory address of C6 is given to move, and the previous move value of B4 is erased. With this new memory allocation, data part is input and the address part is given. The value of start, which was waiting at B4, now comes over to C6. Now look at the program portion. This program is an interesting one. Okay, code of make stack. Assuming choice to be 1, choice is a variable that indicates whether you want to enter more data or not. So the first data is input. So here is the first creation. See, node is, I'll make it a little bigger for better view. Then I can say, where is the data gone? Okay, this will come here. Okay, it comes in. Right. Now, node start is a new node. That means allocation of memory for start, where it was starting with A2. Now we take input. The input goes in for start dot data because data is the integer part. And the first one is created, the constructor will take care of putting null in it, that we saw in the previous program example in the previous video. And now while choice is equal to 1, that means as long as I want to carry on, a new node is created which is named move, and then its data is entered, like you want to enter more data. So now enter the next data. Moves data is input. So moves data part, which is first time move got the value of 20. So here is the data part of the second element. And then moves next became what start was. That means start, which was holding A2, was allocated to the address part of move. Then this gave me this value here. If you look into the picture, you will see this was my move in the previous round. If you see, yes, this was my first time move, and here A2 is allocated. That is the statement. Okay, that is that statement. Yes, moves next is given whatever start is. So A2 comes over to this part, and then I will say now I will change start and bring it to where move is. So that brings start over to B4. Yes, B4. Now if I want to repeat the process, look at the way the repetition is taking place. That is very nice, beautiful one. How I am doing it repeatedly. Again, I create a new node. Now this creation of new node has got nothing to do with the previous existing one. This is creating a fresh node named move, and then I enter the next data. This part gave C6 to move because new allocation of internal memory was done. Now with this C6 in move, when I enter data, I am entering the next data, which in my list is 30. So moves data is getting 30. Moves next, that box is getting whatever start has. Now start has B4. Start is containing two data. The first one is the data part, integer 20. And the second part is an address, which is an internal value, which was A2. Now start, which is holding B4, that is an internal address, is allocated to moves address part. So moves address part gets variable of same type, which is start. Start has B4 in it. It is not an external value. Note that it is an internal value, which therefore comes and sits over here. And start therefore switches over to wherever the last is. Because this is a stack, therefore we are supposed to get last in, first out. So if I now travel this, I will get 30's access first. From there I will come to know wherever my next data is, which is in B4. When I go to B4, I will get access to 20. From there I will get to know wherever my next data is, which is in cell number address memory address A2. I'll go there, I will get 10, and from there I will know nowhere else further to go. Now this is just a small view of the linked list formation. This one you can pause the video and see how the elements are getting allocated one after another and where is the beginning point. Well, this one makes the introduction to how to make stack. Okay.